Hi class, today we're going to look at our MyInteger assignment for week 6. It's quite involved, so we're going to take a look at it together and see if we can get this accomplished. So we want to create a class named MyInteger, and then we're going to create a driver or tester class to test our MyInteger class. So our MyInteger class is going to contain an integer data field. So we're going to have one class or instance variable, and we're going to name it value. And this variable is going to store an integer that is passed to us for the current occurrence of this object. Now within our MyInteger class, we're going to have a constructor, and our constructor is just going to accept a parameter value to set the value of value. And then we're going to have a getter method that returns this integer value to our caller, so an accessor method. Now additionally, we're going to have some other methods. We're going to have the method is even, is odd, and is prime. All three of these methods are going to return Boolean values, and they're going to return Boolean values that are true based on their name, of course. And so we're going to get the results back based on the value that's been stored by this class as an instance variable. So that's the value that we'll be testing to see if it's even, or if it's odd, or if it's prime. So let's see if we can get that part created, but we'll go ahead and talk about the other methods that we're going to have in our class. We're going to have additional is even, is odd, and is prime methods that accept integer parameters. These are going to be static methods that return true, again, if the specified value is even, odd, or prime. We're going to have additional static methods, is even, is odd, and is prime, that accept parameters that are of our MyInteger class type value. We'll have two additional methods, equals and equals, the equals that accepts an integer parameter, and an equals that accepts a MyInteger parameter. So we'll be heavily using overloaded methods in this class implementation so that we can see how that works. So it sounds kind of complicated when we're talking about it, doesn't it? Let's create a class diagram, a UML diagram, to break it down. So I'm going to use Visio. I have Microsoft Visio, and I'm going to create a new drawing. And I want to create a UML class type drawing. Now, if these different template objects weren't showing up for me on the screen, I could try some different categories up here. Software would narrow it down and give me that UML class diagram. Creating this UML class diagram, I'm going to put a class object on my diagram. And this is going to be the MyInteger class. Now our MyInteger class is going to have one integer variable named value. I'm going to delete that. Now I need to insert a member after, and I want a line between those two, a separator. I'll put that right there because now I'm going to use Visio to define the methods that'll be part of our class. So first of all, we need a constructor. And our constructor is going to accept our value as a parameter that will be an integer. I'm going to insert another member here. And this will be, my getValue accessor method. So my getValue method requires no parameters, but it will return an integer value. So I will document that on my UML diagram and insert another member. Now I want to have the method is even, and my first is even method, like all of them, is going to return a Boolean, and it's not going to accept any sort of parameter. I also will have an isEven method that accepts other types of parameters, but let's come back to that. For now, let's say we'll also have an isOdd method that returns a Boolean. And it isPrime method that returns a Boolean. That'll get us off to a good start. So that breaks it down a little bit so that it's not quite so overwhelming as it sounds in the instructions. But we see we're going to have a class that's going to have one instance variable. It's going to have a constructor that accepts a parameter of an integer, and it's going to have an accessor method that returns that integer to our caller, which in this case will be our tester or our driver class. And then we'll have an isEven, isOdd, and isPrime method. So let's get down to it. Still sounds a little overwhelming, doesn't it? But no big deal. I'm going to create a new project in NetBeans. I'm going to have NetBeans create my main class, but my project name is going to be MyInteger. And my main class will be named main. This will be my tester class or my driver. So I will eliminate these comments up here and make these comments be worthwhile. Let's see what else we could say at sign-wise. Nothing too exciting. Let's put our own description in here. This class defines an integer value. Our main class will be the driver tester. Great. So we're ready then to create a class called MyInteger. We already have our class main. It's created. It's got a beginning and an end point. It's in our project over here as a source package, or part of our source package, excuse me, and it's named main.java. I'm going to add a new class file to our project. So I'm going to right click on my source packages folder and choose new Java class. I'm going to name this Java class MyInteger. And now I'm ready to create my MyInteger class. Now in our MyInteger class, first of all, we were going to declare our instance or class variables. We'll call them fields, how's that? So we want an integer named value. Oops, and our integer is private. This integer will hold the value for our current instance of our MyInteger class. So now we need to have a constructor. And our constructor is always public, and it always matches the name of our class exactly. And it looks just like a method because it's a special kind of method, but it does not include a return type. So here's our constructor beginning. Now with our parentheses, we can specify any input to the construction of one of our MyInteger objects. And for our MyInteger objects, we would like an integer parameter to be passed to us. And we'll call it val. Now notice all the errors have gone away because our constructor special method is created properly and NetBeans recognizes that. Now the val value that gets passed to us will be used to load our val variable. So now we have a value for that. Now that ends our constructor right there for us, and now we would be able to create an instance of our class. It's not going to do very much, but we could create it if we wanted to. Let's do a little bit more here so that we can actually do some testing of our class. I'm going to create our method getValue. So again, this is going to be a public method because we're exposing our value to other classes. So we're keeping our value safe within our class, but we're going to let other classes see what it is. So in our method, it's going to be public. We're going to return an integer that's going to be our value. And we said in our UML that this method was going to be called getValue. Now we don't need to pass any parameter to this method because this method is just going to return whatever our value variable currently is. So now we really have a fully constructed class here. We've said our class name is MyInteger. We have a constructor that accepts a variable of an integer to set our value. And then we return that value when somebody runs our getValue method. So let's update our tester to test our class. The first thing I need to do is create an instance of our class. So to do that, we've seen we name our class as our data type. Why do you not like it? Well, we'll keep going. So we'll create an instance called an int, and we'll say it's a new instance of my MyInteger class, and I want it to be the number 7. Look, no errors, yay! So we've created an instance of our class, and our instance is called an int. Now let's print out the value of our MyInteger instance and int. So an int dot getValue is what I want to run to print that value out. So now let's try running it. Should be a little bit happier. And there's our number 7, if you can see that. So we created an instance of our MyInteger class. We called it an int, and then we used our instance to get that value to output it in a print line statement. So awesome sauce. Let's do more with our MyInteger now. Type. There's the end of our method. Let's add a little bit more. Now we said that we want to create a method that will tell us whether our variable is even. So I had that method called isEven. Again, we don't need a parameter for this method because we're just going to use our variable value. So we could have like an if statement here, right? We could say if value modulus 2 equals 0, then we know that we could return true, right? Let's return true. So we could do something like that. Except we don't need that word then, do we? Am I doing pseudocode for you? There you go. All right, so we could do that. It doesn't see our return, and that's why it's complaining to me. I would have to say else, return false. But we don't even have to go to all that trouble. We can actually just say return and then our if statement. So now Java is going to take the value, use it in a modulus command to divide by 2 and see if there's a remainder. If there is no remainder, meaning it equals 0, we'll return a value of true. If there is a remainder, we'll return a value of false. So let's see if that works. We'll go back to our main and let's print out our int is even. And let's see what happens there. Now we get 7 and false. It says, nope, that would be false. It's not even. So what if we try 6? Let's run it. 6 and true. Oh, awesome. So it's working. How easy was that? Just one line of code. So what about our is odd? Can we make it super duper easy also? Well, let's see again. We could say, if this is not equal to 0, something along those lines. Do you want to do it that way? Or do you want to use our is even method? So many things we could do. We'll just make this not equal 0. Now we've reversed the order of our condition, so our isOdd method will return true if our remainder from our modulus command is not 0, and false if it is. Does that make sense? Do a little bit of commenting here. So as we create our methods, notice that we're using public as our access level, Boolean as our return type, and then our method name. If you notice, we're leaving out that keyword static, because as we create this class, our MyInteger class, it is not static. It's an instance type class. We want to be able to keep multiple instances. What does that mean? Well, that means in our tester, we could create some more MyIntegers. I could create another int method instance. Say, okay, you're a MyInteger, and you are 43. Now for that instance, I can say, get the value. I can get whether it's even. Let's try it is odd. I'll add a string there to be helpful. Okay, so now we're creating another instance of our MyInteger called another int. So let's run this and we should see our output for our original integer, which is the number 6, and our output for our new integer, which is the number 43. Notice that we're being able to execute all of these methods for our specific instance. So here's our 6, and it true, it is even. Then our another integer is 43. Is it odd? true. So we're seeing correct output as we test our class. So notice how our tester class or our driver class is just making sure that things are working properly in our actual class, our MyInteger. Okay, so let's check our diagram here. So far, we have our constructor, we have our getValue method, is even, and is odd. So we still need to add our method is prime. Finding that. And of course, you better have to look up that formula, how to find out if something is prime. So to determine if a variable is prime, we're going to use some code here that will help us. First of all, if the number we're concerned with is 1 that was passed to us, or the number that was passed to us equals 2, then we know it's prime. We don't need to do any more work, right? Because 1 and 2 are that small, prime. Now, otherwise, we're going to go into a loop. And we're going to base this loop on an integer named I, and we're going to start I at a value of 2, because we've already taken care of 1 and 2, right? So now we were going to execute while I is less than or equal to our number that was passed to us divided by 2. And we're going to add to I for each increment of our loop, or each iteration of our loop. So notice what we're doing here. If our number is 3, we're going to be setting I to 2. Is I less than or equal to 3 divided by 2? No, so we would just add to I. Now when we do get to a number that is evenly divisible by 2 or greater than I, we're going to take the modulus again of the number and see if it's even. Oop, where am I? Or evenly divisible by I. If it's ever evenly divisible by I, as we execute this loop, we know that it's not a prime number because it was evenly divisible. Now, if we get out of our loop, meaning that we've done all the testing for our variable, we know that it is a prime number. We checked for every number less than it to see if it was evenly divisible, and we did not find an instance of that. So we know that it is a prime number. Now, you want to check the math on that. I think that would be a good plan. But we're concerned about our class right here, so I'm going to add in a tester for that. I know that math is glorious. So it would be something like another int prime Oops, let me go back there. I don't want to pass a number yet. I want all of these to be our value variable. Sorry about that. We'll do that here in a minute and we'll get to change them again. Okay, so that should be our value variable. And then on my tester, I should not need to pass a variable yet. Now, what about our other integer? Is it prime? Can I still check? I sure can. Our method, or our instance, is still available for us to use to check to see if it's prime. Okay, so now that output line will tell us about whether those two integers are prime numbers or not. I'll run it. So yay, I see, first of all, my first integer is 6, and yes, it's even. My second integer is 43, it's odd. Is it a prime? True, it is. Is my first integer prime? No, it's not. I see I've got a spacing error there, right? Let's fix that. And then everything looks good. So we're testing all of our different methods and everything's just hunky-dory. Now I'd like to mess up the whole works a little bit because we need to add some additional methods. So what we need to add now is that we need to add a new is even, a new is odd, and a new is prime. So let's see if we can do that. Did it do it? Oh, it did. I can get rid of that line there. Maybe. Excellent. Okay, so this is even is going to expect a parameter as input. We'll say it's going to be called num. Still going to return a Boolean. Now our isOdd method is going to be the same thing. It's going to expect a parameter. It's an integer that it will call num. And our isPrime method is also the same. Oops. So now we're going to create these methods that are supposed to be static, huh? So let's create these static methods in our class and see what that means to us. So far, the methods we've created have been instance level methods. That means that they were dependent upon the current instance of our MyInteger and its associated value. These new methods are not going to be that way because they're going to be static and they're going to expect a parameter to be passed to them to create the response. So let's try our isEven first. I'm going to copy our isEven method and paste it. Now right away, notice the compiler is upset and it says you already have this method. Why no, but my instructor said I have to create it again. Well, let's fix it. We're going to tell Java this instance or this version of our method accepts a parameter of an integer and we want to call it num. Now notice how the error went away. That's because the compiler sees now we have a different signature for this method. So one occurrence of our method expects no parameter. Another occurrence of our method expects a parameter. So now those become different methods and the compiler can tell the difference. How does one get run versus the other? Well, it's a standard overload. If the call to isEven contains a parameter of an integer, this version of isEven will be used. If it doesn't contain a parameter, this version of isEven will be used. So we don't need two versions doing this math. Let's make our static isEven static. And that means that we're only going to have one instance of this method in memory at any one time. And all of a sudden now it's complaining about our value variable. It's saying your value variable is an instance field. You can't use that in a static method. Why? Because a static method can only be loaded into memory once, and an instance is loaded into memory once for every instance. So what am I going to do? I have to use my parameter, num, instead of the value from my class. So now what about this version of isEven? Should I just leave it duplicating the same code? No. What I should do is change this so that I use my isEven helper method, and I'll pass it the value of our class level field. So now my new isEven method takes a parameter. Using that parameter value, it returns the Boolean equivalent as to whether this is odd. Now, this static method, again, is only going to be loaded into memory once. So no matter how many instances of MyInteger we have, there will only be one instance of the isEven that expects an integer parameter loaded in memory. Okay, so let's do the same thing with isI. We're going to copy it. And notice that we get an error. Can't have this duplicate method. As soon as we say, oh, I need a parameter of an integer type, and I'm going to call it num, then we have no error. But as soon as we make our method static, now we have an error again. We cannot use our instance variable. We have to use the value that was passed to us as a parameter instead. Now, instead of having isOdd duplicated, our instance version of isOdd will call our static version, passing in the class level variable value. So now we should be all kosher. Let's do our isPrime. This one's going to be a little bit more of a bear. Why don't we just make this one be our static? Okay, just like in our others, this one we'll call our static isPrime. We'll make this one static and say it expects an integer called num. Now we've got some changes to do here. Num, 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 and finally num. Now be thinking about what we're doing here, because now we're saying all of our code, all of this logic, lives in a method that's only loaded in memory once. And we just call that method anytime we need to, so we don't have to have that code hanging along with every instance of our MyInteger class. Okay, so now we're good. We did some major changes though, right? Because now our original methods are calling these new static methods. So we better test and make sure we didn't break anything. I'm going to run the same version of that code. Again, I see 6, true, 43 is odd, true. Is 43 prime? Yes. Is the first integer prime? False. Okay, so everything's working good. We have a lot of methods going on here. Let's see what's going on. Can we try it? I would like to set a breakpoint here on line 15. So I'm going to right click and toggle a breakpoint. And I'm going to try to debug my code. Now I'm sitting here with the debugger running, ready to create an instance of MyInteger. So if I click step into, I should see my constructor being executed, because of course to create an instance of a class, we run the constructor. When I run the constructor, I will see my class level variable value gets set to the val that was passed in, 6. There it is. And so sure enough, it's set to 6. It's the end of my constructor. I can return back to my main. Now my main is going to print that out. It's going to be doing a lot of system printing stuff. You can always click through it if you want, see what's going on, or you can jump over it and try to get back to your code. And now we're back and we're going to print out. If we look at our output, we should see that we output that 6 because we ran the get value method. Now if we step into again, we'll see that we're going to go into our class. It's kind of hard to see it. I had it too far, and it's going to let you see what's going on, so I'm going to let you try to do that. Keeps doing everything. I'm not in the right place. Let me turn that off. So I hope you get the idea. It's jumping into, it's showing me too much system stuff. Stop running. It's jumping down into your class and running that code that's part of your class. So we saw that everything is working. We're getting the right output, even though we added in these new static methods that have the same name, but we're getting some overloading going on here that we're only using the appropriate one based on our call. So now we need one more, and this one is going to be based on our current MyInteger object. Let's do a copy again of our isEven method. Now for this version of our isEven, we're going to be expecting a parameter that's going to be of the MyInteger type. Let's add that to our Visio diagram. I think I'll try copying all these again. And pasting them. Oh, not that one. I thought that worked awfully good that last time. All right, that'll work. So now our new isEven. Instead of using a num that's an integer, we're going to use a different variable name, the int, and it's going to be of type MyInteger. So it's going to be a different instance of the integer. And we're going to create one of these methods for each again. Okay, so we're ready here. We're going to create new methods that are going to use parameters that are MyInteger instances. So for our data type, we'll use our class MyInteger, and we want this to be called the int. So now, instead of calling isEven and passing in our value from our class, we're going to make this a static. We won't be able to do that. We're going to use our isEven MyInteger instance that was passed to us, int, and use its getValue method to find out whether that value is even or odd. So now we have one version of isEven that expects no parameters, one version of isEven that expects an instance of a MyInteger object, and our final static version that expects an integer number. And this is the class that's actually doing all the work, right? Because here's where we're doing the math and returning the true or false value. So let's do the same thing for our isOdd. Now this version of isOdd is going to be static. It's going to expect as a parameter a MyInteger instance that it's going to name .int. Again, instead of returning the isOdd true or falseness of value, we're going to use .int, and we'll use our getValue accessor method to get the value of the current integer. Okay, so let's do the same thing with our isPrime. Now in our isPrime, again, we're going to make it a static. This is just such a great example of overloaded methods, and it really does give you a lot of great experience. So it can be a little bit heavy, but it's a really great little project. So now our isPrime method is also going to be set up to expect an instance of our MyInteger object, and we can return our .int objects getValue result. Run that through our isPrime method to figure out whether an object is prime or not. So now we've declared some additional methods that we can test. Looking at my project right now, we create a couple of an integer objects. Let's move this around. We'll create the second one up there. Let's create a third one. Third int. What do you want this one to be? Let's make it something that is not prime. We'll do 18. How's that? Okay, so we have some miscellaneous printouts happening here just to test our class. Let's add a few more. This time I'm going to say something about our third integer, and I will use its instance to get its value to print out. Now let's use some of our other classes, or methods, sorry. Third integer equal to first integer. Well, to answer that question, well, we really need a couple more methods, don't we? And those would be our equals methods. Let's add them to our UML diagram. I'm just going to right-click and insert member after. I need a new method called equals, and I want to be able to pass it an integer. And it's going to return a Boolean. And then I want another version of that. that uses a MyInteger object. Now we can compare that to the class's instant value. Okay, so is the third integer equal to the first integer? We're going to say, using the third int, use its equals method. And what we want you to compare it to is an int. And I want to print that out nicely. So let's see how that works. Okay, so now my equals is working. I can pass it in an instance of our integer, an int, and I can use an instance of our integer as the basis for the comparison. So let's add a little bit more to that output. Third int will get its value equal to first integer. Let's add a little bit more here. Okay, so let's see what that should output. We should see third integer plus the value of the third integer equal to first integer plus the value of first integer. I guess that that question mark is redundant. We'll get rid of it. Okay, let's run this. Okay, so third int 18 equal to first integer 6, false. That is correct. Now, what if we ran an instance here that was equal? Let's test that. Could I try to create an integer and pass it in? So as a parameter, I could create a new instance of a MyInteger. Notice that this instance would not have a name. These instances have names. This instance would not. But it's going to be another instance that's going to have a value of 18. So let's run that now. Let's see, third integer. Not getting my 18 out of my new MyInteger value. So that's all right, because we'll look at that on another chapter. Let's just create another instance of a number that's equal to 18. Okay, so now we're checking it to see if it equals that 18. Let's see what we get. It still says false. We've got something wrong there, huh? Let's check it. So in our equals, where is our equals? Is prime. I lost my equals. Well, we better create those. I lost them because I didn't create them yet, huh? Now our equals are going to return a Boolean. Easy enough, huh? So if our number equals our value, we're going to return a true. You can see why I thought I'd already created them here. Okay, so anytime we have a parameter that is our class, we've got to use our getValue method to get the value. So let's see if that makes things come out a little better. In our tester. Oh, that's better. 18 equal to 18. Yes, it is. So remember how I was trying to do that new instance? Let's see if that didn't work just because of our little problem there. Okay, let's try it. Oh, that's better. No, so you see we can instantiate a new instance of our class by using the new keyword as the parameter to a method. So lots that we can do here, pretty crazy. Now, this is a really, I guess, in-depth class. Gives you lots of ideas and I hope suggestions in your head for how you could do things, for many things. But how do we get this into REPL? Let's take a look. We want to have a lot of different things here. Oh, looks good, looks good. So our main method is going to be kind of a bear. Now, one thing that we can do with REPL is we could create a file. And we know in NetBeans we created a new class file. So let's do the same thing with REPL. And I want to create a new file and I'm going to rename it and it's going to be MyInteger.java. Now in my MyInteger.java file, I'm going to copy all of my code from NetBeans. And paste it into REPL. Oh, my beautiful code. Now my main, I have got a lot of tester information already in NetBeans. So again, I think I'll just copy my whole main method. I know it's not going to be exactly right, but it'll be close, and then I'll paste that. All right. I can zoom in a little easier in REPL. Now, what do I want to do in my main? First of all right, we've got our class created, all of that stuff. So we want to update the main method. Prompt for an integer. I'll put my import, and then I'm going to create a scanner instance. Now, if you notice, the scanner is just like our class. It's just a class that was created by Java or somebody. So here's our scanner, and then we can just use a print. And of course, we should be using our methods that we created earlier. I'm just trying to economize our time in the video. So instead, I will just create some quick code here. I'm going to grab an integer named input. And get our next integer from our input. Okay, so let's create our instance of our class using the input. So now that meets this first criteria prompt for an integer. Create an instance of MyInteger using the supplied input. Output results from the is, even, and is prime methods for the instance. Okay, so we want it to look like this. So I'll get rid of all of this extra junk. And I'm going to print out, first of all, and int dot get value. So it's going to print out our number, whatever was input into our program. And then we'll output this message is even, question mark. And then we'll use our int and ask for its is even method. Get rid of all this extra stuff here. Okay, so that's going to say, is it even? And then we're going to output that false or true, depending on what was input. Now I'm going to copy this line of code. And it can be hard to create the exact output that our tester or driver tester wants. So that's why we want to do this together. Is it prime? Now we can call our is prime method for our instance. Okay, prompt for another integer. Now, because I've already declared the input, I need to delete that int keyword so that I don't get an error. And I'm just going to be making it say enter. Oh, I'm not supposed to say please. It should say enter an integer. That's why sometimes it's better to just copy this from REPL. Enter another integer. And then for this one, we're going to output some great stuff here. Let's see what that is. We're going to output, first of all, oh, we got to create an instance. We'll make this an int2 from this new input. Now for this one, we want to, output some great stuff here. We want to say, first of all, our number, which looking at this test case could be 15, right? So, and int2.getValue will return the value of that integer, and then we can say, is it odd? And int2 dot is it odd? That should take care of this line of output here. Now our last thing is running just another variable to see if it's equal to itself. So what we're going to see is if these two integers are equal to themselves. First of all, I'll use this output line that's already here and fix it up. So I want to output whether our first integer is equal to our second. So we'll do an int.getValue to output the value of our first integer. Then the message is equal to and then we'll use our second integer. And add just a little bit more. And after our question mark, we'll put a space, and then we'll use the method to compare the two. And int dot equal and int2. Okay, that should produce that second to last line of output. Now our last line of output for our tester requirements. We're going to delete this one out so that we can start from scratch. And what number are we using here? We're using our second input or our first. Oh, our first. So we're going to say an int dot get value is equal to we'll just put in 5 and then a question mark, and then we'll actually just call an int dot equal passing the parameter of 5 in directly to see if that comes out equal. Okay, I think that should give us our output that is required. Let's see what that cleans up. Not too much. Okay. 22. MyInteger. Let's see what our method names are. Is even, is odd, is prime, equals. Okay, so we fix both of those. So our first test value, if we're using the test expected output, would be 5. 5 is even, false. 5 is prime, true. Enter another integer. That looks like it matches up. I'll put in 15. 15 is odd, true. 5 is equal to 15, false. 5 is equal to 5, true. Missing a space, missing a period. What about it? So this is one of the most complicated outputs you'll have to produce. Let's see if we can run again. Oops, not a statement. Put the parenthesis in the right place, huh? Five, 15. Looks good. Okay, everything's pretty happy, so I'm going to test it. And it looks like it's all going to line up good. So everything should be just the way we want it. Now that should be everything that you're going to need to do to create this REPL and to get it all working and get this assignment all turned in. So we've stepped through pretty much all of it for you because it is quite complicated, and I want this one to be a learning experience much more than a frustrating experience. And I feel like even with us doing it together, there's still so many concepts in here to wrap your brain around that it can be a lot of work. So continue to practice, do the best you can, be thinking about how all of these different method overloads are causing the right code to be executed and how we're being able to implement multiple options for our class users through a very small amount of methods and code in those methods. So I hope you've enjoyed this one. It's super fun. Thanks.